Carbon and its compound. Chemical properties of carbon compounds and some important carbon compounds. Combustion, oxidation, addition reaction, substitution reaction, ethanol, ethanoic acid. Chemical properties of carbon compounds. In this section, we will be studying some important chemical properties of carbon compounds. Since most of the carbon compounds are hydrocarbons and used as fuels, we shall study first combustion. Combustion, the process of burning of carbon compound in air to give carbon dioxide, water, heat and light is known as combustion. Alkanes burn in the air to produce a lot of heat, due to which alkanes are excellent fuels. Methane or butane are used as cooking gases in our homes. The saturated hydrocarbons generally burn in the air with a blue, non-salty flame because the percentage of saturated hydrocarbons is comparatively low, which gets oxidized completely by the oxygen present in the air. Oxidation. The carbon compounds can be easily oxidized on combustion. In addition to this complete oxidation, we have reactions in which alcohols are converted to carboxylic acids. We see that some substances are capable of adding oxygen to others. These substances are known as oxidizing agents. Addition reaction. The reaction in which an unsaturated hydrocarbon combines with another substance to give a single product is called an addition reaction. Addition reactions are a characteristic property of unsaturated hydrocarbons, that is, of double bond or triple bond hydrocarbons. Substitution reaction. The reaction in which one or more hydrogen atoms of a hydrocarbon are replaced by some other atoms is called a substitution reaction. The substitution reaction of unsaturated hydrocarbons with chlorine takes place in the presence of sunlight. If the substitution of hydrogen atoms take place by chlorine, it is called chlorination. Here, methane reacts with chlorine in the presence of sunlight to form chloromethane and hydrogen chloride. One hydrogen atom replaced by chlorine atom and we get chloromethane. Some important carbon compounds. Ethanol and ethanoic acid. Ethanol. Ethanol is commonly called alcohol and is the active ingredient of all alcoholic drinks. Its formula is C2H5OH. Because it is a good solvent, it is also used in medicines like tincture iodine, cough syrup, and many other tonics. Alcohol is formed by the fermentation process of sugar. Main sources to get alcohol by fermentation process are fruits like apples and grapes, grains like wheat and maize. Alcoholic fermentation is the conversion of sugars into alcohol and carbon dioxide by the action of enzymes presenting yeast. Properties of ethanol. Physical properties. Ethanol is a colorless liquid and has pleasant smell and burning taste. It is lighter than water and has a low boiling point of 78 degrees Celsius. It is a good solvent. Ethanol is a neutral compound, thus has no effect on any litmus solution. Ethanol containing 5% of water called rectified spirit or commercial alcohol. Chemical properties. Combustion of ethanol. Ethanol is highly inflammable liquid. It burns in the air to form carbon dioxide and water and produce heat and light. Oxidation of ethanol. When ethanol is heated with alkaline potassium permanganate solution, it gets oxidized to form ethanoic acid. Dehydration. Dehydration of an alcohol means removal of water molecule from it. When ethanol is heated with excess of concentrated sulfuric acid at 170 degrees Celsius, it gets dehydrated to form ethane. During dehydration of ethanol, molecule H from the CH3 group and OH from CH2OH group are removed in the form of a water molecule, resulting in the formation of ethane molecule. Here, sulfuric acid acts as a dehydrating agent. Tests for an alcohol. Alcohol can be tested by the following tests. Sodium metal test. Add a small piece of sodium metal to the organic liquid, taken in a dry test tube. If bubbles of hydrogen gas are produced, it indicates that the given organic liquid is an alcohol. Ester test. The organic compound to be tested is warmed with some glacial ethanoic acid and a few drops of concentrated sulfuric acid. If sweet smell occurs, it indicates that the organic compound is an alcohol. Uses of ethanol. There are various types of uses of ethanol and various sectors where ethanol is used. Ethanol is used in the manufacture of paints, varnishes, medicines, perfumes, etc. As a solvent, many organic compounds which are not soluble in water are soluble in the ethanol. As car fuel along with petrol and as a fuel in the spirit lamps. As alcoholic drinks like beer, whiskey, wine, etc. As an antiseptic to sterilize wounds and syringes in the hospitals. Ethanoic acid, acetic acid. The common name of ethanoic acid is acetic acid. The formula of ethanoic acid is CH3COOH. A dilute solution of ethanoic acid in water is called vinegar. Vinegar contains about 5 to 8% acetic acid. Vinegar is used as a preservative in pickles. Physical properties of ethanoic acid. Ethanoic acid is colorless liquid having sour taste and a smell of vinegar. The boiling point of ethanoic acid is 118 degrees Celsius. A cooled and freezed ethanoic acid has a glass-like or ice-like look. It is miscible with water in all proportion. Chemical properties of ethanoic acid. It is an acidic in nature, but is a weak acid. It turns blue litmus to red. Reaction with carbonates and hydrogen carbonate. Ethanoic acid reacts with carbonates and hydrocarbonates to evolve carbon dioxide gas along with the formation of salt and water. 1. Reaction with sodium carbonate. Ethanoic acid reacts with sodium carbonate to form sodium ethanoate and carbon dioxide gas. When sodium carbonate is added to a solution of ethanoic acid, brisk effervescence of carbon dioxide is given off. The salt formed in this reaction is sodium ethanoate, which is commonly known as sodium acetate. 2. Reaction with sodium hydrogen carbonate. Taking a boiling tube and put 0.5 grams of sodium carbonate in it. Add 2 ml of dilute ethanoic acid to the boiling tube. The brisk effervescence of carbon dioxide gas is produced. If we pass this gas through lime water turns milky. Ethanoic acid reacts with sodium hydrogen carbonate to evolve brisk effervescence of carbon dioxide gas. Uses of ethanoic acid. The uses of ethanoic acid are as follows. For food preservative. For making cellulose acetate. For manufacturing of acetone and esters used in perfumes. For preparation of dyes, plastics and pharmaceuticals. For rubber, coagulation from latex. Summary. Carbon and its compounds are some of our major sources of fuels. Ethanol and ethanoic acid are carbon compounds of importance in our daily lives. That is all about this subtopic, students. We will see soap and detergents in our next topic. Keep learning!